Hello, everybody. Today we're going to be talking about multiple representation. I know, big fancy words, and you're going to know how to use them and what they mean very soon. Multiple means more than one. Okay? Let's say Susie has won multiple medals at the track meet. That means she won more than one. Representations are the ways that something can be shown. All right, there you go. So multiple, more than one. Representation, the ways that something can be shown. So we're going to talk about more than one way to show something. Okay, so let's go through some examples. All right, just let me come up with a few and see what we can come up with. How about potatoes? I don't know about you, but I eat a lot of potatoes. All right, and my favorite way to eat potatoes is as fries. Okay, every so often I like some potato chips. They're potatoes, but those are two different ways to show them. And then finally, with lots of butter and maybe some gravy, I love mashed potatoes. Okay. Another answer might be Spider-Man. Okay. Spider-Man, we know, is a comic book character, but there have also been Spider-Man TV shows, and most recently, there have been Spider-Man movies of all kinds. So again, it's multiple representation means more than one way that something can be shown or used. So potatoes can be fries, chips, or mashed, and a whole bunch of other ways too. Spider-Man, you can see him in a comic book, on a TV show, or in a movie. All right, so think about those things if you ever get confused about the words multiple representations. Now, linear functions can be represented multiple ways. So let me go ahead and start off by saying they can be shown with words. And that sounds simple, right? We all speak. But actually, I think that might be the hardest one. We'll have to look at that example in just a few minutes. The second way a linear function can be shown is with an equation. The third way something might be able to be shown is with a table. The next way is a list of ordered pairs. And we'll be showing you examples of all of these. And finally, in a graph. Okay, so linear functions can be represented multiple ways. Words, an equation, table, a list of ordered pairs, or a graph. Our first example is with words. So let's take just a few seconds to be really careful and just read this. It says, a plant is 3 inches tall when you first measure it. So at the very beginning, we are measuring that plant and it is 3 inches tall. It grows 2 inches each week. That is a multiple representation being shown in words, but now let's make it an equation. Well, we're going to start with y equals. Now, how much is that plant growing each week? It's growing 2 inches every week. And where did it start? You can only start in one place, okay? It's not going to change. The growing's going to change. That's why there's an X there. But it started at 3 inches, and that is not going to change. So the words and then the equation. Y equals 2x plus 3. Now let's go over to the next slide, and we're going to look at, we brought the equation with us, we're going to look at a table and a list of ordered pairs. So the first thing I'm going to look at here is say, okay, I have this equation. Okay, what if I started day 1 and measured it? So no days have passed yet, so my x is 0. So, and we know it started at 3 inches. If you happen to put this in Desmos, 2 times 0 is 0, so all you have left over is 3. That's why when my x value is 0, when I first started counting, my height was 3. Now, let's think about going 1, 2, even 3 weeks, and it's going to grow 2 inches every week. So if it started at 3, plus 2 is 5. Plus 2 is 7. Plus 2 is 9. That's one way we can develop a table. We could also use Desmos and plug this equation in Desmos and then write x equals 0. It'll give us 3. X equals 1, it would give us 5. X equals 2, it would give us 7. X equals 3, it would give us 9. Once we have a table, the list of ordered pairs is pretty quick. So we know the first ordered pair would be 0, 3. The second one would be 1, 5. The third one would be 2, 7. And the fourth one would be 3, 9. All right, so make sure that you're just very careful. Like I said, you can do this in your head, or I suggest use Desmos. Okay, and the way I would set that up in Desmos, let me go ahead and show you. I would type in Desmos on my first line, y equals 2x plus 3. Then on my second line, I would type x equals. And I would just plug in different numbers. I would start with all of the numbers that I had here in my table. X equals 0, x equals 1, and it'll continue to give you the value of y. All right, let's see what our next one is. This time they've given us the points that we've already figured out, and we are going to graph them. So let me go ahead and grab my highlighter. The first point is 0 and 3. 1, 2, 3. Okay, the second one is over 1 up 5. 1, 2, 3, 4, 5. The next one is 2 over 2 and up 7. 1, 3, 4, 5, 6, 7. All right, and the last one is 3, 9. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there you go. That is your line shown as a graph. You will be doing these and moving between all the forms very easily very soon. I am sure of it because we believe in you.